like the word justify, we don't like the word show. It means we've got to fix it, right? I know it's not the same as is it continuous. It shows that it is continuous or not. So show that the following function is continuous or not at x equals 3. Before I do any work, I'm going to run through this in my brain, right? So what am I going to do in my brain before I show it or justify it? Quality in 3. I know 3x minus 3 is continuous. I know 6. I know x squared are continuous. And then you can ask me after 3 uses because I know that the only place I'm concerned with is 3. So I'm going to put 3 in at the top. What do I get? 6. That's good because it's the same as the middle one. That's the same as the function value. What do I get if I put 3 in the bottom? What's that? Not continuous. Which condition does it fail? It only has to fail one to not be continuous, but I do need to show that. Okay, good. The limit doesn't exist, right? That's the easiest one. And I'm going to show that. The limit as x approaches 3 from the left. And again, remember when it says show or justify, I'm going to overdo it a little bit. Again, that doesn't mean write me a paragraph. Just show any work that you have to show. So why did I go ahead and show this piece here? That's the equation I'm using for the left. So I let AP know that I know how to find the limit from the left. I use the left-hand piece of that function. I'm now going to find the limit from the right. I'm going to let AP know that I know how to do that. Those are not equal, right? Should I make one more little statement? What's the one more little statement I should make? It's not continuous. Answer the question. You could have answered it at the very top. You would say, so f of x not continuous at. Any questions about that one? So that's how you do a mathematical justification. So it's show or justify, we've got to put in a little more work. It's a little less intimidating the second time around seeing a justification. Do you agree? First day it was a little scary, but now you're going, okay, it's explaining what I found out in my head. Suppose f of x has a horizontal asymptote at y equals 6. An infinite discontinuity at x equals -4 and a removable discontinuity at x equals 5. What is one possible equation? First, let's go define what an infinite and a removable discontinuity is. I imagine you know somewhere deep down inside what is an infinite discontinuity. An asymptote. So it's got an asymptote at x equals -4. And what is a removable discontinuity? A hole, and you can cancel out. So we have an asymptote, vertical asymptote at -4, a hole at 5, and a horizontal asymptote at 6. How could I make that happen? And there are a lot of different answers. But what has to be on the bottom? X plus 4, why x plus 4? Gotta have a vertical asymptote. We don't want it to cancel. We want it to be all by itself. Yes, the removable one, we want that one to cancel out. So I want an x minus 5 on top and on bottom to get the whole. Right? So far, so good? Now, how do I make a horizontal asymptote be 6? What is the only way I can have a horizontal asymptote that's a number, not 0 or the powers have to be the same. So what is the power on bottom just because of my vertical asymptote and my hole? Squared. So I need another x on top. make that happen. Probably the easiest way is to throw that up there. You could have done an x minus 2 and not put an x plus 4 up there because that would make the whole one not very possible. So that's one possible answer. You could see that 6x portion could be a lot of different things and still get the same answer. Other three pieces have questions about those? Yep. That's one equation. I wouldn't. You will learn later that in AP Calculus we just do it. In fact, I'm going to open this last portion, which don't do this on tests. I want to see where it's stuff out. That's on a real test, and we'll talk about it when it gets closer to practice. If the answer is 1 plus 2 plus 5 on the non-calculator test, you leave it like that. Because you might mess it up by adding it. They will grade it. They will grade 1 plus 2 plus 5 on AP. Right? We'll practice that later. Not yet. We're not ready to leave 1 plus 2 plus 5. For now, we'll call that. Okay. It's f of x. So we're going to learn two very important theorems. They are almost too obvious to even say, but they're so important that we need them. And so we're going to learn the intermediate value theorem today and the extreme value theorem. The reason we haven't learned them yet is because we haven't had a definition of continuity. And if you read the first sentence in both of the theorems, it says f of x is continuous. So we now can use these theorems. They are almost so obvious it hurts, but we're going to draw a picture and show you what they mean. So I'll give you a second to write the intermediate value theorem down so that you can listen as I'm talking. You probably saw the intermediate value theorem in pre-cal or algebra 2, and it's going to be equally, what's the word for it? Uneventful in calculus. It definitely seems uneventful, but it has a lot of applications. We will use these theorems a lot more as we go. I'll show you a couple problems today, but they get more important in calculus later. They are abbreviated IVT and EVT. And I'm actually going to state the extreme value theorem a little differently. I got that out of a book. There are other books that have a little bit more concise definition of extreme value theorem. Okay, so let's talk about the intermediate value theorem first. It says if f of x is a continuous function on AB in brackets. What does AB in brackets mean? From A to B, including A and B, right? It is it's what's called a closed interval. So f of x is continuous on a closed interval A to B. So I have A back here, B over here. And I have f of A and f of B, right? Will you agree those would be f of A and f of B, the y values? It says L is a number between f of A and f of B. Somewhere in here, there's a number L. Then there is at least one number C on AB, so a number C in between A and B, such that f of C equals L. What that says is if I continuous function, right, go from up here to down here, do I at some point have to cross that line right? Okay, here's a real-world application of this. You boys, when you went home after 7th grade, and you were like 4'9", right? And you came back in August, and you were like 5'5". What had to happen sometime over the summer? You had to be 5'2" and 5'3", right? You had to be every height in between. Everyone agree? That's what the intermediate value theorem says. If we have a continuous function, height is continuous, right? Unless you have extension. You're just growing at a continuous rate. So if you have a continuous function on a closed interval, then you have to hit every value in between those two y values. Almost too obvious, right? But that's what it says. So the intermediate value theorem says that a continuous function, if you go from f of a to f of b, you have to hit every y value in between as you go down. That's all it says. Any questions about that? Now, quick application of this. Have y'all ever found zeros on your calculator? You know how it tells you to find a left bound and a right bound? It's really asking you, it doesn't say it, it's really asking you to find a positive value and a negative value. And what it does is it applies the intermediate value theorem hundreds and hundreds of times. It's closer and closer and closer, positive value, positive, until it gets so little that it says, okay, there's a zero in between here. And as you know, your calculator is always an estimate. You know what I'm talking about? That's how it finds it. It uses the intermediate value theorem over and over and over again. Calculators are dumb. They're just really fast at being dumb. And so they just guess a bunch of times until they get close. That's how you calculate functions using the intermediate value. So, if f of x, the extreme value theorem says, if f of x, and you might actually want to write this down a little differently, but I'll read it the way it's written and I'll give you another option. If f of x is continuous on the closed interval ab, you have to have that. Then this one says that there are two values c and b on ab, such that f of c is the maximum of f of x, and f of b is the minimum on f of x. In a more concise statement, the extreme value theorem says if you have a continuous function on a closed interval, you have an absolute maximum and an absolute minimum value on that function. You attain an absolute minimum and you attain an absolute maximum. It's what the extreme value theorem says. And I'm going to talk a little bit to you about why it has to be continuous on a closed interval for this to work. I should have mentioned that on the last one. Does everyone know why the last one had to be continuous for it to work? Because if it worked, you could skip, right? We could get extensions put in our legs and magically be taller. So I kind of talked about it in a real world sense. And we had to have a closed interval because we had to have an f of a and we had to have an f of b. So that's why. First one was like, let's look at this one. So if I have a over here, b over here, and I have an f of a and an f of b, and somehow I get from f of a to f of b. Make it strange. Could be anything. Would you agree that there is a lowest value and a highest value? Now, it does not tell us where the lowest and highest values are, but we have one. That's all the extreme value theorem says. Now, why is it continuous on a closed interval? Well, if it's not continuous, we could have an asymptote in between. An asymptote would end up having a maximum or minimum, wouldn't it? Because you wouldn't have a maximum or minimum. Why the closed interval? Well, what if this were an open circle at the bottom? Does that have a maximum or minimum value? No, because the maximum is where the open hole is, and you don't ever get there. You always get closer and closer and closer, but never get there. So that's why it has to be continuous and it has to be on closed interval. So that's the intermediate value theorem and extreme value theorem. I imagine you feel completely enlightened that you learned tons of things today. I mean, I kind of feel like you're probably going, no, Miss King, right? Of course. That's kind of how those theorems feel. these, and I will tell you again, there will be more as calculus goes on related to intermediate history that I do. But we'll do a couple. If f of x is continuous on negative 10 to 10, and f of 3 equals 7 and f of 2 equals negative 8, does f of x have a 0 on the interval negative 10 to 10? Justify. We don't like that word. We'll do it. We don't like it. We have to justify. Some of the questions on tonight's homework are more continuity questions. They're not all intermediate guys here. But first of all, before I justify, what's the answer? Is there a 0 between negative 10 and 10? How do you know? Because the graph is continuous, and let's sketch a quick picture. f of negative 2 is negative 8. f of 3 is 7. It is continuous, which means I can only draw it without picking up my pencil, right? Now I get across the x-axis to get from down here to up here. Yeah, right. Of course I am. But now I have to justify that is the tough part. So, does f of x have to have a 0 on negative 10 to 10? I would recommend answering the question first. Again, if it's for the AP open response question, you probably get a point for saying yes. There is a 0 from negative 10 to 10. Justify. Well, what's the justification? The intermediate value here. And how can I apply the intermediate value here? Well, first I have to say that it fits the conditions. So I'm going to say f of x is, what do I have to say about f of x? Continuous. On negative 10 to 10, so I'm showing that it's continuous on a closed interval, right? No. Either way. Either way. On the interval negative 10 to 10 or from negative 10 to 10. Either one. Of course, okay. What else do I need to say? Perfect. 0 is between. I like your wording is perfect. I mean, how are you getting that wording? Practically reading the theorem, right? I'm practically -2 is 3. We talked about that notation, right? You guys go. That means C, and this little symbol here means an element of. It's actually a little E. It looks a little bit like an arrow. I don't know if arrows are lost in college, but C is an element of -2 to 3. C is in the interval -2 to 3. Such that f of C equals 0. So I went through it. Now, could you have used all words and such symbols? Absolutely. I just like to teach you some math symbols every now and then. So I went through and pretty much completely restated the theorem, except with my numbers thrown in. Do you think you're going to have to memorize the theorem? Yeah, because you can't do this if you don't know the theorem. So this is the theorem you will need to memorize. It's actually on the screen because later in your life. It will be on the test, so you need to know it for this test too. Yes. Prove that the function intersects the x-axis on the interval 0 to 2. So just another one of the exact same thing, almost. Prove that the function intersects the x-axis on the interval 0 to 2. Now, I do want to mention as you're writing this problem down, the intermediate value theorem is great for proving that something does exist. It does not tell you if something does not exist. Just a quick sketch of that. If I have f of A and f of B up here, does that guarantee I don't cross the x-axis? No, because I could dip down like that, right? So just a mental note, the intermediate value theorem proves that something does exist. It does not prove that something does not exist, and it also doesn't help you find it. It just is what's called an existence theorem. But it actually is quite important in calculus. Okay. So how am I going to go about proving that this intersects the x-axis on 0 to 2? And we could just walk through the theorem probably, couldn't we? What's the first thing I need to say? And is a quadratic continuous? F of x is continuous. I can go ahead and say on 0 to 2 it's actually continuous everywhere, but it's definitely continuous from 0 to 2. What else do I need to find to even answer the question? Because right now I don't even know it yet. I kind of do because it said proof, so I figure it's. What do I need to find? F of 0. Everyone agree f of 0 is 2? And I need to find what? F of 2 is 4 minus 8. Say 4 plus 2, -2. And then what would I say? Zeros between? 2. Zeros between? 2 and 0. F of 0 and f of 2. Have I met all of the conditions of the intermediate value theorem? All the condition parts. I haven't finished. I've met all the conditions, right? So then I can say, therefore, by the intermediate value theorem, there is a C lies between 0 and 2 such that the new symbol such that f of c. You see why reading a math textbook in college might feel like you're speaking a different language. By the time you get there, this will be part of your vocabulary.
Where does it say, like, what's up with 0 versus 2 and that's 2?
You have to say this part, so you have to know what those values are. This part isn't actually part of the theorem, but I can't use this part of the theorem if I have to have it.
The FOC equals 0,
It could. This could have said, show that f of x equals 1. And I actually could have gone for the exact same proof because 1's between -1 and -2 and 2. So then I would just say 1 is between f of 0 and f of 2. Therefore, by the intermediate value theorem, it says f of c equals 1. So it could be any number. 0 is a common one because there's
so like that theorem could have been 1.
Yeah.
If you
any number that's in between these two. In fact, the intermediate value theorem would say that I get every number in between. Okay, that is all the new stuff for today. I thought that I would throw up a few review questions, see if you know how to do those. See if we feel good about them. So, see if you can do these two. Feel pretty good about both of these? You don't actually have to do them. I mainly just want to know that you can. Do we want to work either one of these two? Feel pretty good about those? So, I just want to find out what we know how to do and don't know how to do. What about these two?
what about
The top one.
Top one, okay. So on the top one, if I plug in 5, I get a number over 0, which means I have a vertical asymptote. And so from the left to right, what's the limit as I approach a vertical asymptote? Good. Either infinity or negative infinity. Agree?
Mm-hmm.
So I'm going to pick a number really, really close to 5 that's on the right. What's the number to the right of 5? 6 or even 5.00001, whatever I pick. You agree that I get a positive number?
Mm-hmm.
So this is approaching positive infinity.
So what it's either infinity, negative, doesn't exist.
Right, and it does not exist if this isn't a plus. Like there's nothing here.
Yeah.
This one from the left would be negative infinity. The right positive infinity. And double side of this does not exist. The bottom one, plug it in. Right? Sometimes we see sine and cosine and freak out. Don't forget your first step is like 2 pi over 3. Y'all do know that all pi over 3s are 60-degree angles. So we have a 60. I'm just going to draw a picture. If you don't remember sine of 2 pi over 3, that's okay. This is 1, 2, radical 3. The 1 is negative because I'm going to the left. Follow how I got that. So it would be great if you just knew it, but if you don't, that's how you get it. So sine is radical 3 over 2. Cosine is actually up 2 pi. Doesn't really know how I got up 2 pi. 3 pi over 2 pi over 3 times 3. And so cosine of 2 pi, which is right here, is 1. So the answer is radical 3 over 2. So now it's just plug it in limit. You know your unit circle. That was the easy question.
I would be confused when we do that because when we did it, the 1 was always on the
True. If you are using the unit circle, which is only a memorization tool, then the hypotenuse is always 1 because it's a unit circle. However, if you forgot your memorization tool, it probably won't help you. So this is a way to get it back if you've forgotten a piece of it. And so I'm going back to geometry, way back, and I'm just drawing a 60-degree triangle. though I could have the side ratios be radical 3 over 2, negative 1 over 2, and 1, that's not the easiest 30, 60, 90 set ratios. The easiest set of 30, 60, 90s is the 1, 2 radical 3. And so this is just my triangle to help me get it back. Now, if you have the unit circle memorized, this is an unnecessary picture because you already know the answer. That explanation makes sense. So, you know the answer, skip the picture. But the picture is a way to get the answer back if you forgot. And I always draw those because sometimes you'll forget those. And I want you to be able to get them back if you forgot it on an AP test. Okay. Do we need to see one of these? Am I good on those? What about this one? This would be a non-calculator question. So do we need to talk about natural log of 1? What is the natural log of 1?
1.
What is...
Which one's E? Is E?
So if I were to draw E, E's going on top. E to the 0 power is 1, right? So that's the point 0, 1. So what would the inverse be? You just switch the x and y. 1, 0, right? So this is the point 0, 1. Logarithm has the point 1, 0. Right? Because you switch the x's and the y's. So natural log of 1 is 0, right? So I get 1 over 0. What does that mean? Non-existent, right? We've got a vertical asymptote of some sort at that point. That does mean you need to know the natural log of 1. That is a number that comes up a lot. You might want to just write it in your notes. Natural log of 1 is 0. There are only 3 numbers that you need to know on natural log. You need to know the natural log of 0 is undefined because it's that asymptote. You need to know the natural log of 1 is 0. And you need to know the natural log of E is... What is the natural log of E? 1, because those cancel. So those are the 3 values of natural log that AP will just expect that you know. They won't expect that you know any others because they aren't natural numbers. Unless you can get it with properties of logarithms. But those are the 3. They'll just expect you to know those values. And you can tell that.
Teachers and students, clear your attention please. We need all fire marshals in the high school office.
This will be on video, but we aren't learning anything. What about this bottom one? What do we do first? Plug it in. What is the cosine of 0? 1. So I get 1 minus 1 on the top. And on the bottom, what is sine of 0? 0, right? Everyone agree? Sine of 0 is 0, which means I have 0 over 0. What's that mean? There's more work to do. Everyone agree? So, any ideas? And this was a really bad, yucky, horrible problem. Look at Kelsey. Everyone agree that with trig identities, sine squared is 1 minus cosine squared? So, it's tempting to use one of our special limits. This one's not a special limit problem. This one's a factoring problem. The trig identity involved. Why is it a factoring problem now that we've write that trig identity? What do you know about 1 minus cosine squared? It factors into difference of perfect squares. You probably had to do that on some trig identities. And then 1 minus cosine just cancel. And now I can plug in 0 and I get 1 over 4. That one was string technology that I've seen in a while.
We have to know that for the test.
Yep. The trig identities, the Pythagorean ones, you need to know those. You don't have to know every trig identity you learn, half angle, weird ones like that. It's okay that you don't remember those. You do have to know the sine squared plus cosine squared is 1 and the rearrangement for that. This is 1 on top, and then when I plug in 0, cosine of 0 is 1, 1 plus 1 is 2. That's another one of those. They use delta x instead of h, but it's the same. That's the end of my section. Any questions about that? We did a little bit of review and a little bit of new stuff. Your homework is due tomorrow. That one thing is tomorrow, and the review assignment on Friday. Test is Tuesday. Any questions? Did the little review was it helpful?